Have you ever just stopped and wondered how your phone, well, how it just knows things? How it seems to magically sense what's happening around it? It really does feel like magic, but honestly, what's actually going on is way more interesting. So let's pull back the curtain and uncover the hidden senses of the devices we use every single day.
I mean, think about it. You put your phone up to your ear for a call, and poof, the screen goes dark so your cheek doesn't accidentally hang up on someone. Then you pull it away and it lights right back up. How does it do that? This one simple everyday action, it's actually the key to a much, much bigger story.
You see, the answer to that question, and a whole bunch of others, is all about how our technology manages to perceive the real physical world. There's this constant, invisible conversation happening right there in the palm of your hand, and today, we're going to listen in. Okay, so to really get to the bottom of this, we have to start here. Our world and the world inside our computers speak two totally different languages. I mean, it's like one person speaking in these smooth, flowing sentences, and the other person only speaking in short, super precise codes. They just wouldn't understand each other. So, first up, you've got the analog world. This is the language of nature, of reality. Think about the sound of your voice. It rises and falls, it's smooth. Or the way the temperature in a room changes. It's gradual, right? Analog signals are continuous. They don't just jump from one value to the next, they flow. And then you've got the digital world. This is the native tongue of computers. Now, unlike that smooth analog flow, digital signals are all about distinct steps. They're what we call discrete. They use a very limited alphabet. Yep, usually just zeros and ones. That MP3 you're listening to? It's not a real continuous sound wave. It's a bunch of tiny digital steps that do a really, really good job of pretending to be one. And this table right here, this shows you exactly why computers are all in on digital. Just look at noise resistance. An analog signal, like an old radio station, can get all staticky and fuzzy super easily. But a digital signal, it's just ones and zeros, so it's way more resistant to that kind of interference. And the big one, storage. You can copy a digital file 1,000,000 times, and that millionth copy is perfect. It's identical to the original. Now go try doing that with an old cassette tape. It's just not going to happen.
Okay, so right away, we've got a huge problem. We live in an analog world, right? But all of our amazing devices are digital. So how in the world do they talk to each other? How does your phone take the analog sound of your voice and turn it into digital data that it can shoot across the internet?
So here's the bottom line. We need a translator. We need some kind of go-between that can take all that rich, messy, continuous information from the real world and translate it into the clean, precise language that computers can actually work with. And just as important, it needs to be able to translate it back.
And that amazing translator? It's called a mixed signal system. This is truly the unsung hero of all modern electronics. It's the bridge that connects the two worlds. It's what lets our digital gadgets sense real-world stuff, like light, sound, motion, and then process all that information with perfect digital precision.
But, for a device to even use that bridge, it first needs a way to actually perceive the analog world. It needs senses. And that, my friends, is where sensors come into the picture.
A sensor at its core is pretty simple. It's just a little device that detects some kind of physical property. Could be heat, light, motion, pressure, you name it. And then it turns that detection into an electrical signal. That signal is the very first step to getting information from our world onto that bridge and into the digital brain of a computer. There's this quote that I think just nails it perfectly. It says that sensors are the eyes, ears, and sense of touch for our tech. And it's so true. Without them, our gadgets would be completely clueless, just sitting there blind and deaf to everything happening around them, totally stuck in their digital bubbles.
And the whole process is actually pretty straightforward. It's basically 3 steps. First, there's detection. The sensor reacts to something, like a change in light. Second, transduction. That's a fancy word for converting that physical reaction into an electrical signal. And finally, output. It sends that signal on its way to be processed by the system's brain. That's it.
All right, so now we have all the pieces of the puzzle, right? We've got the analog world, the digital world, the mixed signal bridge between them, and the sensors that act as the gatekeepers. So let's put it all together and finally solve the mystery we started with.
First, you got to realize your phone isn't just a phone. It is a sensory powerhouse. It is absolutely jam-packed with these things. The accelerometer feels gravity and knows which way is up. The ambient light sensor checks the brightness of the room. The magnetometer works like a compass. It's basically a complete sensory organ that you carry around in your pocket.
And there it is, the answer to our original question.
It's the proximity sensor. It detects the analog presence of your face, a real, physical object, and sends a signal through that mixed signal bridge to tell the phone's digital brain, hey, something's right up close, power down the screen. It's so simple, but so brilliant.
And here's another one you see all the time. The accelerometer and the gyroscope are constantly sensing the physical forces of motion and gravity. So when you turn your phone sideways to watch a video, they send a signal that tells the software time to rotate the screen. It's not magic at all. It's just a really cool conversation happening between the physical world and the digital mind of your phone.
But here's the thing. This conversation isn't just happening in your phone, not by a long shot. Once you know what to look for, you'll start to see this incredible unseen connection between the analog and digital worlds absolutely everywhere.
Just think about your car. The sensors that beep when you're backing up, the sensors that automatically turn on your wipers when it starts to rain, and the critically important sensors that deploy an airbag in a crash. It's all the exact same principle. Same goes for your smart thermostat adjusting the temperature or a heart rate monitor sensing your pulse. This tech is quietly and constantly making our world safer and smarter.
And when you zoom out, you realize our entire modern world is pretty much built on this foundation. It's this non-stop, invisible dialogue between physical reality and digital intelligence, and it's all made possible by these tiny sensors and the systems that let them speak the language of computers.
So that leaves us with a really fascinating question to think about. As these sensors get smaller and smarter and more connected than ever before, what new senses are we going to give our technology? What will our devices be able to perceive about the world and maybe even about us in the years to come? Now that is something to think about.